Section 3. Sealing Management of Equipment. Sealing is the technical measure taken at the joints to prevent leakage of liquids from equipment, pipelines, etc. The types and statistical scopes of sealing points. Sealing is divided into dynamic sealing and static sealing. The sealing parts of components are called sealing points. Therefore, sealing points are classified into dynamic sealing points and static sealing points. Dynamic sealing involves various mechanical and electrical equipment, including the sealing among continuous motion in machine tools, and between two coupled parts with reciprocating or rotating motion, like sealing of compressor oil, pump shafts, rotating shafts of various reactors, etc. These seals are classified as dynamic sealing points. Static sealing refers to seals between equipment, pipelines, and accessories, where there is no relative motion between the coupled parts during operation. Static sealing includes flanges on equipment and pipelines, various valves, plugs, quick connect joints, oil indicators on pumps and accessory pipelines, electrical equipment such as transformers, oil switches, cable heads, instrument baffles, control valves, and other equipment coupling parts are also static seals. These sealing points are included in the static sealing point statistics. Any leakage is counted as a sealing point. All the leaks, including static sealing points, or leakage caused by welding, cracks, sand holes, corrosion, or other reasons, can be covered in the leak point statistics. Now, let's count the types and numbers of these sealing points. There is 1 flange, 4 gate valves, 1 oil plug, 1 blind plate, 3 couplings, and 2 direct joints. How to determine if it is a leakage point. Next, we will introduce the inspection standards for sealing points. First, inspection standards for static sealing points. First, for equipment and pipeline joints. Visually check for no carbon buildup, no smoke, no leakage, no stains, no leaking agents, and no dirt. Second, for pipelines or systems carrying gases such as acetylene, coal gas, ethylene, ammonia, chlorine. The welded and other connection parts can be tested for leaks using soapy water with no bubbles. Alternatively, precision test papers or reagents can be used with no color change. Third, for oxygen, nitrogen, and air systems, use thin test papers 10 mm wide, 100 mm long to check for no blowing effect, or use soapy water to check for no bubbles, etc. Second, dynamic sealing leak point inspection standards. First, shaft seals of various reciprocating and centrifugal compressors. Leakage is not allowed during the initial use. Minor leakage is allowed towards the end of the operating cycle. For toxic, hazardous, explosive, or easily contaminated mediums, samples should be taken for analysis 300 mm away from the packing gland. The concentration of toxic gases should not exceed the safety limits. The lubricating oil packing gland should not leak oil. The piston rod should have an oil film. Second, crankcase covers of various reciprocating compressors. For example, the bearing shells of turbo compressors are allowed minor seepage, but they must be cleaned regularly. Third, bearings lubricated with oil should not leak oil. Fourth, leak rate of pump packing. In the initial stage, it should not exceed 20 drops per minute, and in the final stage, no more than 40 drops per minute. The leak rate of high-pressure plunger pumps should not exceed 15 drops per minute. Next is the calculation of the leak rate. The leak rate of dynamic sealing points is calculated as number of dynamic sealing leak points divided by the total number of dynamic sealing points multiplied by 100%. The leak rate of static sealing points is calculated as number of static sealing leak points divided by the total number of static sealing points multiplied by 100%. Part 2. Standards and Management of Chemical Leak-Free Plants. First, the standards for chemical leak-free plants. The Chemical Leak-Free Plant Initiative strengthens sealing management to reduce leaks, drips, and spills, improve efficiency, lower consumption, eliminate pollution, and ensure the health of workers. The standards for a chemical leak-free plant are as follows. First, a sound sealing management system with clear responsibilities and comprehensive management. Second, static and dynamic sealing files, management logs, and leak blocking records. Complete and accurate technical documentation for sealing management. Accurate statistics and application of sealing points. Dynamic sealing leak rate should be equal or less than 0.2% with no significant impact on the plant's appearance. Third, maintain a static sealing leak rate less than 0.5% with no noticeable leaks in the plant environment. Fourth, all production workshops in the plant must be leak-free workshops. The overall equipment integrity rate should be greater than 90%, and the main equipment integrity rate should be greater than 95%. Finally, to establish a chemical leak-free plant, the enterprise should set its own leak-free workshop standards according to the above criteria, and begin activities to create a leak-free workshop. The enterprise should conduct a self-assessment based on the above standards and conditions. Write a self-assessment summary and fill out the chemical leak-free plant application form. Submit the application to the higher supervisory department for approval. After confirmation by the provincial department, the plant will be named and issued a certificate and plaque. Strengthen daily management of the chemical leak-free plant. Once certified, a chemical leak-free plant or enterprise must strictly follow relevant regulations and systems for daily management. This ensures continuous improvement in the management level of chemical leak-free plants. The chemical leak-free plant certificate is valid for 4 years. The certificate must be reapplied for renewal 6 months before the expiration date. How to create a chemical leak-free plant. All production equipment and pipelines in operation must have static and dynamic sealing files and logs. The statistics for sealing points must be accurate. Sealing files should include process flow diagrams, static and dynamic sealing point registration forms for equipment, sealing point registration forms for equipment pipelines, and the contents of the sealing point classification summary table. Sealing logs should include the distribution of sealing points over time, leakage status, leakage rates, etc. Second, establish a complete sealing management responsibility system at all levels. Sealing management responsibilities must be clearly defined. The plant, workshop, and company must regularly conduct inspections, evaluations, and comparisons. Third, carry out activities to create and consolidate the leak-free plant. Leak elimination and blockage work should be regular, specific, and institutionalized. Leak points that cannot be eliminated immediately should be documented, with a plan for their elimination. Fourth, conduct timely inspections, statistics, and reporting of sealing leak points. Fifth, organize research on various sealing technologies. Promote the application of new sealing technologies and materials. This concludes the course content. Thank you for watching.